Good morning, class. So we want to look at sum to infinity. In case you have a series of GP expression in which it continues to infinity and you are asked to evaluate the sum of the finite of the series. So, like for example now, find the sum of the infinite progression. Like for example, you have this series. So the sum to infinity of any series is equals to A divided by 1 minus R. This formula is actually from the sum of n term, the sum of the first n term of GP. Remember that the sum of n term of GP is A into bracket R raised power n then minus 1. This is when n tends to infinity, then you are going to have A left and your R 1 minus R, in as much as your R is between 1 and R plus 1. So we are going to have this is a formula for sum to infinity in solving any question. Now, if you look at this series now, for example, A is the first term, A has been given to you to be 3. You can easily get your R, which is your common ratio, which is going to be the first term divided by the second term, or the third term divided by the second term, or the fourth term divided by the third term. So from here, you can calculate the sum to infinity. You can see that the series continue. The series continue. So how can you find the sum of what you've seen and what you did not see? That is sum to infinity. So therefore, sum to infinity will definitely be in this series will be A. A is 3 divided by 1 minus R. R is 1 divided by 3. That is 1 over 3. Which of course is the same thing as saying 1 over 3 divided by 1. It still be 1 over 3. 1 over 9 divided by 1 over 3 is still going to be 1 over 3. And 1 over 27 divided by 1 over 9 is still going to be 1 over 3. So the common ratio remains the same to be 1 over 3, which is equal to 3 divided by 1 minus 1 over 3 becomes 2 over 3, which becomes 9 over 2. Therefore, the sum to infinity here will give us 4.5. It means 4.5 is the sum to infinity of this series. This is example 1. Let's look at another example on this same sum to infinity. We have question number 2. The sum to infinity of a GP is 60. If the first term of the series is 12, find a second term. Solution. The sum to infinity is A divided by 1 minus R. And the second term of a GP is A. The second term of a GP is A R raised to power 2 minus 1, which is A R. It means to find the second term, we need the first term and we need the common ratio. If you look at this question, we have been given the sum to infinity to be 60. This is 60 equals to, the first term has been given to be 12, but the common ratio is not given. The common ratio wasn't given. So we can use this to evaluate the common ratio. Cross multiply. So we are going to have 60 into bracket 1 minus R equals to 12. Divide both sides by 60. So you are going to have 1 minus R equals to 12 divided by 60 will give us 1 over 5. Collect like terms. So R is going to become 1 minus 1 over 5, which is going to be 4 over 5. So our common ratio is 4 over 5. Since our common ratio is 4 over 5, we can then substitute 4 over 5 here inside the equation to get the second term. Therefore, our second term now, which is equals to AR, now eventually becomes, our A is 12 from the question, and our common ratio is 4 over 5. Therefore, our second term is going to be 12 times 4 is 48 divided by 5. How many 5 can we see in 48? That is basically going to be 9 whole number, then 3 over 5, or 9.6. So it means the second term is going to be 9 whole number, 3 over 5, or 9.6. This is going to be the second term. And this is going to be the end of geometric progression. Thank you.